Thanks for coming. So sorry, I'm getting a little bit of an echo. Let me mute myself. Is that better? All right, let's get started. All right, so has anyone felt like this year's been a little bit different as it relates to AI? Like kind of like a crossroads of sorts. Doesn't feel like this long-awaited promise. It feels real, like the way we write code's actually changing. And now we have tools to create user experiences that were like, kind of impossible before. Uh, my name's Devin Chasanoff. I'm a developer relations engineer on the Angular team. I actually joined the Angular team this year, and wow, what an interesting time to do so. So my number one goal as a DevRel engineer has been and always will be to look out for my developers. My success is your success. And so I've spent the greater part of the last 6 or 7 months or so trying to figure out how to set Angular developers up for success in this ever-evolving age of AI. Now, before I move on, I have to imagine some of you might be a bit skeptical, right? Even downright resistant to working with AI. And I can only speak to my own experience. And in my own experience, I've had both positive and negative interactions with LLMs. I've had times where it felt like I was working in direct opposition with my agent. Incredibly frustrating. But I've also had some illuminating moments where I've realized just how incredible this technology is. And with the rapid pace of innovation, I can't remember a time in my career where I've had an opportunity to learn so much so fast. And in this talk, my goal is to share with you basically everything I've learned in the past year or so to better equip you for the road ahead. And while I've approached this subject through the lens of an Angular developer, I think these lessons will apply to kind of general software development. So even if you're not an Angular developer, you'll still get a lot out of this. So before I go any further, it's worth noting my crystal ball is currently in the shop. So this contents of this talk are my own observations and opinions. I don't know what the future holds, but this talk is grounded in my own real world experiences. So even if I'm completely off base here, I'm confident that this talk will, at a minimum, give you a lot to think about. So with that, let's kick things off on a light note. Are we all going to lose our jobs? I have no idea, but I sure hope not. What I do know is that vibe coding is likely here to stay. However, I don't expect vibe coding to be the future of software development. Has anyone here built like a simple web app using something like Gemini Canvas? It's pretty incredible, but there's a limit to how much you can achieve, right? It has its place in prototyping, and I can even see a world where spinning up a simple web app is comparable to creating a Google Doc. And given how web apps enhance functionality, I can see this becoming a legitimate part of professional business going forward. But that's not why we're here. Chances are, if you're attending IJS, you're working on something a little more complex than a simple single-page application. And that said, if your role today is just creating these types of simple apps, I hate to say it, but AI may take your job one day if you don't evolve. So let's shift our attention to something we can refer to as AI-powered engineering or perhaps vibe engineering, which in my opinion is far more interesting. How can we 10x our productivity with AI? So in order to figure that out, let's take a look at what it's like coding with AI today. A former colleague of mine posted something on LinkedIn recently about his experience coding with AI, which I thought was comically accurate. He said something along the lines of coding with AI is like having 10 junior engineers churning out code for you while having access to a senior engineer sitting on your shoulder. It's pretty awesome in many ways. On the flip side, junior engineers can make a lot of mistakes, produce low quality code, and they can lack context as compared with a senior engineer who knows where all the bodies are buried in the code base, right? And similarly, it's pretty awesome having access to an expert in any domain, one prompt away. However, LLMs make mistakes, pretty confidently, I may add. So it may be a dangerous game to rely solely on the output of LLMs. Now, at this point, you may be saying to yourself, it sounds like I'm going to have to copiously review a ton of LLM generated code, right? And fact checked all the answers. How exactly is this any better? Well, as models get better, I do expect the AI assisted coding experience to dramatically improve. But I expect we'll always need talented engineers in the room. And here's the biggest reason why. Only you know what you're trying to achieve. When it comes to defining objectives, you are the single source of truth. So are we just glorified code reviewers? I don't think so, but let's come back to that after a discussion on why LLMs may struggle to write high quality code. All right. High quality code. It's kind of a subjective term, right? So I have this distinct memory of the 10th grade when I was in English class, and my teacher actually asked us to grade our own papers before she gave us her actual grades. And naturally, I gave myself an A plus. And as it turns out, I was actually the only person in the class to do this. I thought that was kind of odd, but my teacher basically asked me something along the lines of like, where do you get off giving yourself a perfect score? And I explained, I worked really hard on the paper. I believed in it. And frankly, if I thought the paper could be better, I would have written it differently. You see, I didn't have the experience and context that my English teacher had to properly evaluate my work. So if you ask me, my inability to write at a higher level and grade myself is really a reflection of my English teacher's abilities. And that's the same problem with LLMs. They're only as good as the data that they're trained on. For a more concrete example, let's shift our attention to the Angular team's journey, getting LLMs to generate high quality code. So the rapid growth of AI adoption is only part of the reason why this has been such an interesting time to join the Angular team. Perhaps you've heard the term the Angular Renaissance, maybe. So over the last 2 years or so, the Angular team's just been on a roll, introducing novel features like to improve developer experience and framework performance, things like signals. We've got zone lists, standalone components, control flow syntax improvements, server-side rendering, and that's only a few. There are a ton. And people were coining this the Angular Renaissance. You know, there's so much innovation happening. And I thought to myself, what an incredible time to be joining the Angular team. And then the funniest thing happens. Vibe coding and AI assisted engineering just blew up. And when we went to generate Angular apps with AI, the code didn't meet our standards for high quality code. It didn't use signals, it used old control flow syntax, and it didn't use standalone components. What was happening? Well, it turned out that all of our innovation came back to bite us. Although the code compiled successfully, models have been trained on data from older Angular code rather than defaulting to the new modern Angular syntax. And this was a major problem. On top of that, LLMs excelled in vibe coding with languages like React, for example, because of the massive corpus of code and the flexibility of its function-based approach, even if the generated code wasn't necessarily scalable or maintainable for, significant apps. A lot of people came to the conclusion that LLMs just produce better React code. And some went as far as to say, React's won already, it's over. So if you're an Angular developer, should you stop using Angular? I see some heads nodding. That's never a good thing. So let me answer that question with another critical question. Assuming LLMs generated comparable quality code for all frameworks and languages, which one would you use? Whatever your answer is, that's what I'd suggest you use for AI-generated code. And the reason I bring this up is because Angular fell victim to something I like to refer to as the innovation time lag, which represents the period after an AI model has been trained, during which technologies keep evolving, meaning LLMs don't inherently have knowledge of the latest and greatest features until the next model is trained and released. And I'd say choosing a framework based on an LLM's current temporary knowledge is a bit short-sighted. It prioritizes a third party's tools and limitations over the framework's foundational strengths. And by that logic, we're just done innovating, right? We're just destined to use the same features that were out when this AI revolution started. But we all know that's not true. Frameworks and languages, technologies will continue innovating, and I expect the pace of innovation to actually accelerate with the advent of AI. I think most of us would feel the same way. And with each new release, the models will be trained on more up-to-date information. They'll get better at generating code. And I think this time lag is actually proof of our momentum, and it's a good problem to have. So that all sounds great, but how does that help me today if I'm an Angular developer, right? Or a developer using any technology that's, facing similar challenges? It doesn't, but perhaps I can. So let's come back to this subjective term I threw out before, high quality code. This can mean a lot of different things, right? Does it use modern syntax and follow best practices? Is the code well written such that it can be easily debugged, scaled, and maintained in the future? Does it follow design and stylistic best practices of your organization and team? There's a lot to unpack there, but the key takeaway here is quality code is written the way you think it should be written. Now, this is a somewhat controversial point. I've heard many folks say, who cares about the implementation? I'm 10x more productive and the app is working. This is fantastic. And others are saying that productivity should come second to the quality of the code. I say, why not have your cake and eat it too, right? I don't think we're quite there yet, but I'm optimistic that the future will give us productivity gains without sacrificing code quality. And in the meantime, we have some tools to bridge the gap now and in the future as we keep innovating, because this innovation time lag is just going to keep shifting. So these tools will be very important. Enter context engineering. So if you've been keeping up with the hottest buzzwords in AI, perhaps you've heard that prompt engineering is dead. Apparently, context engineering is the new hotness. In case you're not familiar, here's a brief definition of context engineering complements of Gemini. Context engineering is the practice of designing and optimizing the information provided to an LLM to elicit the most accurate, relevant, and useful response. It's a specialized subset of prompt engineering that focuses on structuring the context, the data, instructions, and examples you feed the model to guide its reasoning and output. So if you think of an LLM as a brilliant but inexperienced new hire, you wouldn't just give them a vague task, right? You'd provide background documents, instructions, examples of what a good outcome looks like. So context engineering is the formal process of doing just that for AI. And framing this in a different way, LLMs basically execute stateless functions and their output is only as good as their input. At a basic level, LLMs inputs or context consist of the data they were trained on, the conversation history with the user, and the user's prompt. Now, we can enrich that context in a number of different ways, especially as it relates to generating code. For example, you can use retrieval augmented generation or RAG. You can use rules files, MCP servers, extensions, some combination of those, and I'll go through a bit of those in just a minute. So I've personally spent a lot of time experimenting with rules files and MCP servers this year, but before I share my learnings, we should probably discuss what it is we're trying to engineer here. So how do we engineer your context? That is, the context that when provided gets the LLM to generate what you think is high quality code. One easy solution that requires nothing other than your existing knowledge is to add information in what are called rules files. And these rules files augment your prompts to introduce higher quality output, and this is pretty powerful. In fact, you can use this technique to influence how the code is generated, as well as how the LLM agent interacts with you. So just to give you an idea, what you're seeing here on the screen, I recently developed an AI-powered Angular tutor. And this was created with nothing but a single rules file, right? So it dynamically tailors the lesson to your experience level. It provides open-ended exercises to emphasize learning and retention. It answers questions. It even checks your work, right? And amazingly, I didn't write a single line of code to make this. It's entirely powered by a rules file. And if you're interested in checking it out, you can access the Angular AI tutor on the GitHub repo, or you can use the Angular MCP server where it's exposed there. More on that in a bit. So with those same learnings in mind, the Angular team released our own official rules file, which you can add to your project to produce high quality, modern Angular code. So the Angular team's definition of what high quality code looks like. So the official Angular rules file works really well, but it's based on the most recent versions of Angular. What if you're a developer using a different version of Angular, an older version? And what if your dev team follows best practices that diverge from Angular's best practices, right? Does your org have its own, style guidelines, for example? How do you incorporate that? So let's think about the context that we provide LLMs in 4 levels to create an agent that operates exactly how you want while generating high quality code. So at the lowest level is the data that the models are trained on. This represents the basic output the LLMs will generate by default without any additional context besides your prompt. Next are the rules and guidelines provided by framework and language maintainers, if available, to generate their version of high quality code. And I actually expect this area to grow, actually maybe become an industry standard going forward. I can even envision like a rules file management system akin to NPM or something but it's for rules files, so you could easily just pull in rules files to your project super easily. And also keep in mind that you're most likely going to have to use multiple technologies rules files, unless you're just strictly, coding with a single technology, which is kind of rare. And then you can provide rules and guidelines that are unique to your team and organization to make the code output adhere to your team and organization, say, what version you're using of Angular, your style guidelines, your best practices. And as an added bonus, this is a great way to enforce style guidelines across your organization. I mean, think about how many PR comments you can avoid with this. And keep in mind that this might also include framework best practices that the maintainers missed. More on that in a sec. And remember, if you're integrating multiple technologies without established standards for how they actually work together, you may want to address that too in your rules files. And finally, our personal rules, like for the individual. And seeing as the code will likely follow your team and organization's best practices and guidelines, I find this level of context very useful for influencing how the agent interacts with you, like I did with the AI tutor. So for example, if you were to look at the tutor's rules files, you'd see instructions on like how to be a tutor, right? And here are some other general instructions I've found useful when working with LLMs myself. One that I use commonly, don't make any changes unless specifically requested by me. This prevents the LLM from doing too much, gives me a little bit more control. Another, which I've found helpful for Angular projects in particular, is to have the LLM run ng build, check for compile errors, and then fix them, which is pretty cool. And actually, this is part of the Angular official rules file, but I bring it up because it's a pretty useful one. But pro tip here, put a limit on the number of checks it can do. That way you don't run into a situation where the LM just keeps fixing and unfixing something, which I've been in before. And then finally, some folks find it really helpful to use this as a project or feature description, like a blueprint, so the LLM knows, the steps it has to take. And alternatively, I've seen rules files that actually instruct the LLM to create a blueprint or specification at the outset. It lists the project requirements, the execution steps, completion criteria. This can be a really powerful mechanism to create context on the fly that steers the LLM in the right direction throughout the course of a project. So with that, we now have an agent that leverages underlying power of an LLM. It follows official framework best practices, It adheres to your organizational design guidelines, and it operates in a way that's conducive to your own personal workflow. Our very own personal coding super agent, right? Well, even with our new super agent, that still leaves a bunch of pain points and open questions, like where do these rules files come from? What if I miss some details in my rules files? How can I make updates? What if it's an org-wide update? How do I push that out to everyone? What if it might be an org-wide update, but I need to check with someone first? What's the process for that? Well, this points to a number of pain points associated with this approach, which include dynamically importing multiple rules files, addressing edge cases, and persisting these changes across sessions and even teams. And even if you were able to figure out how to do all of this, and I've very much gone down this rabbit hole, it's really challenging to make these adjustments on the fly and manage your rules files without totally taking me out of my flow and killing my productivity. Well, I kept going down the rabbit hole, and I've personally found a bit of success leveraging MCP or Model Context Protocol servers to help alleviate some of the pain points I was experiencing. And in case you're not familiar with MCP, we'll turn to Gemini once again for a definition. An MCP server is a service that exposes specific tools, functions, or data to an AI agent through a unified interface defined by the Model Context Protocol. It acts as a bridge handling complex interactions with external systems like databases, APIs, or local files, allowing AI models to access and use these resources without needing to understand their underlying code or complexity. So this has been an ever-growing practice among organizations, and the Angular team recently released our own experimental MCP server, which you can use to access the AI tutor, like I said before. You can get Angular best practices, you can list Angular projects, and you can actually search the official documentation. And similarly, you can augment your agent's abilities by creating your own custom MCP server. And one of the things I've been experimenting with in my own custom server is serving rules files dynamically from, say, Firebase storage rather than hard coding them into my environment. And this provides a level of flexibility I've found incredibly useful, especially as it relates to managing several rules files in a given project. And for demonstrative purposes, I created a dashboard with Angular to manage and update these rules files. And here you can see rules for Angular, Firebase, and some of my personal rules, all of which I can load dynamically into any dev environment where I'm coding with AI. And taking this a step further, this is where it got kind of cool. I added some tools to my MCP server to dynamically update my rules based on my interactions with Gemini, which is what I was using. For example, here's some of the things my tools can do. All right, so one tool listens for corrections plus phrases like do this from now on, and it updates my rules file to adhere to whatever my command was. Another one, sometimes LLMs generate code. I don't like it. I update it myself manually because it's easier to do that. So what I'll do is I'll trigger a tool that compares with the LLM output versus my finished state of the file. It figures out the diff, why that went wrong, and then updates the rule so that it doesn't happen again. I have another tool that accepts a golden code example, and based on like that perfect code example, it just goes ahead and creates rules based on whatever's in there. This is a really cool way to kind of bootstrap a rules file if you don't have anything and you need to get started, but you've got some good code. You can even just run this on your existing code base, if you have good code that you're starting with. And then finally, I have another rule that just analyzes the entire conversation between the LLM and the user. It figures out how the rules file could have been different to get the user's desired outcome the first time. And then it updates the rules file accordingly. So this has been super fun to play with. And in my system, all of the changes produced by my tools, they get added as rule proposals, which I can accept to update a given rules file. So I did this like for demonstrative purposes, as well as to provide an added level of control. Now, keep in mind, all of these rule proposals come from my dev environment. They're not coming from this app, right? The agent, for example, Gemini CLI uses my MCP server to perform the analysis and generate the rule proposal and automatically add all the rules to my to Firestore without even taking me out of my flow because it's all happening in the chat. I don't have to leave, which is really cool. And if that all sounds like a lot of work to you, that's because it is. So much so that I can actually envision an entirely new industry I'm calling context pipeline engineering, almost like DevOps, but for AI context management. And I can see this as a team that's responsible for managing the AI rules, as well as the pipeline and tooling used to keep them up to date across an entire team or organization. And this would provide any developer on the team with free access to all of the context generated by the context pipeline engineering team and the broader organization, while also allowing them to seamlessly contribute to the organization's context. That way you can create consistently high quality code across a team. And this can also be really helpful in doing things like migrating different versions and changing models, especially since when you upgrade models, your edge cases and adjustments might change as well. So you need to monitor that. And I want to emphasize the word pipeline here. So I'm about to share one of what I think are the most meaningful lessons I've picked up that I can share with you to make working with AI better right now, today. So have you all heard of the term work slop? Yeah. I'll use Gemini one more time. So work slop, a recently coined term that describes the uninspired, low effort, or often thoughtless material produced with the aid of general artificial intelligence. So I find work slop is actually the result of giving the LLM bad inputs. Bad input means bad output. But in my opinion, bad input may not necessarily be a direct result of laziness or low effort. You have to know how to get what you want. And just like any engineering problem, the key is to break the problem down into smaller steps. So let me give you a non-software related example to illustrate my point. So my wife doesn't code. I'm not even sure she really understands what it is I do. But she crushes it in her field. She's a rock star. And as you can imagine, I've been talking about AI a lot at home. So we were talking about how one might go about kind of automating the entire process of creating, ideating and creating a slide deck. And it was important that the slide deck reflected her ideas, her voice, style, and design. So we broke this down into a few steps, right? First, she used Gemini Deep Research for ideation, brainstorming, and forming an initial draft. Then she iterated on the draft with Gemini until it was what she wanted. Then she had Gemini create a high-level outline for the slide deck, followed by coming up with the proposed slides, which included a title, content description, and proposed imagery. Once she had the substance nailed down, she was okay with it. She had the LLM create the actual bullets and the actual imagery and graphics that went into the presentation. And then the final step was getting this into her themed slide deck. And I was actually out playing softball with my friends when she attempted this part. I came home to find my wife coding with AppScript in bed. I've never been so proud. In any case, I hope this illustrates the point I'm trying to make. My wife didn't just ask Gemini to make a slide deck, right? She broke the problem into multiple chain steps and audited the output at each step before feeding it into the next one. So taking this a step further, what if we wanted to go back a few steps and then automate the rest of the pipeline automatically? Sounds kind of interesting. So I can actually foresee an entire industry of pipeline products coming to market that help folks address use cases like my wife's slide deck creation, right? Specialized for different industries. But back to, our problems, our issues. The same is true for context engineering, and something I found when I created Angular AI Tutor. In order to update context effectively in the manner that I've described, it's helpful to use a multi-step process to transform inputs into high-quality context for LLMs, auditing and adjusting the inputs with the help of AI in each subsequent step. So we can describe context pipeline engineering as the process of creating systems that automatically update context and dynamically improve LLM output, which may be shared across teams or organizations. And One of the most important aspects of producing high quality rules is evaluating LLM code output. And the Angular team are on the forefront of this challenge. So a couple of weeks ago, we released and open sourced a brand new tool called the Web Code Gen Scorer, which evaluates and scores the quality of AI generated web code. And you can use this tool to make evidence-based decisions related to AI-generated code. You can compare the quality of different models, and you can compare them over time as they change and evolve. And this tool isn't even limited to Angular. You can use it for various different frameworks and languages for generating front-end code. So that all sounds pretty interesting, right? A lot of kind of high-level theoretical discussion. But what does that mean for our jobs? Are the machines just going to write all the code and we're still glorified code reviewers and our primary role is just feeding context to the LLMs? My short answer is no, if you're willing to put yourself in a position to make the most out of AI. So I said this before, I'll say it again. Only you know what you're trying to achieve. LLM output is simply an interpretation of your desired objectives paired with their own trading and context. You're responsible for directing the LLM, and its output will only be as good as the instructions you provide, meaning you are the critical component in the software development lifecycle. In addition, I'm a firm believer that you need to understand the code that you're generating. There's a unique phenomenon I've experienced in vibe coding. I like to refer to it as the unfixable pit of despair. And this happens when you rely solely on the LLM to make decisions and fixes, but sometimes the LLM can't figure out a fix. And in some cases, it'll even make detrimental edits to your code base, creating significant setbacks if you say haven't committed your code. Whoops, I've done that. You need experts that know more than the LLMs to prevent this from happening and uncover fixes where the LLMs can't. LLMs can also come across as incredibly confident when presenting incorrect information. They're giving themselves an A+ on their own code which can even include completely fabricated APIs and properties as a result of hallucinations. It's so easy to fall into the trap of trusting LLM output implicitly, but it's imperative that you be able to challenge them. And this is the part where I tell you that your job is going to be a heck of a lot more fun than just reviewing LLM-generated code. Taking a step back, software engineering in the traditional sense is just using code to solve problems. Code is a tool. Languages are tools. Frameworks are tools. Tools to help us solve real-world problems. Along the same lines, AI is a tool to help us solve real-world problems. For decades, assembly was a fundamental skill in engineering, and then coding languages abstracted that all away. And similarly, you can think of AI as another abstraction in a sense that's going to make you more powerful and productive. I think developer value is moving up the stack from writing boilerplate to architecting systems, defining contracts, and auditing AI output. The most valuable skills are becoming more human. Critical thinking, creative problem solving, product sense, system design, and clear communication, all of which comes from our own technical expertise. And in my experience, I've replaced writing boilerplate code with creative problem solving. And it's a bit of a mindset shift, right? I'm thinking in terms of problems rather than in code. And when you automate the boring stuff, it frees up a lot of time to work on interesting problems with the assistance of a technology that can access and synthesize all of the world's information. And let me tell you, I've been having a lot of fun doing it. And guess what? Every time you tackle a new innovative problem, you can fold that solution back into your pipeline and work on more interesting stuff going forward. So a lot of those interesting problems will be engineering problems, but let's not forget why we do what we do, to create incredible experiences for our users. And the benefits of AI aren't just limited to code generation. We can now create user experiences that were previously impossible or prohibitively expensive. With APIs and SDKs and frameworks for building AI features such as GenKit, Firebase AI Logic, and the Gemini API, to name a few, you can incorporate generative content directly into your apps to create truly dynamic, one-of-a-kind experiences. So as a simple example, earlier this year, I built an interactive choose your own adventure style graphic novel builder with Angular and GenKit. And while this is kind of a contrived example, I hope this opens your eyes to the possibilities of what you can do with AI. And if you're interested in learning more, I open source this app, which you can find at github.com /Angular/examples. And we even hosted a live stream on our YouTube channel where we actually built this live alongside our community, which was super fun. So before we wrap up, I want to share why I'm excited about the future of Angular in the context of this AI revolution. So although some models may currently struggle with code generation, as I discussed earlier, there are a lot of new Angular features that can help streamline integration and optimize performance when leveraging generative AI. Interacting with AI and LLM APIs introduces unique challenges such as managing async operations, handling streaming data, designing responsive user experiences, and error handling, since you get a few more errors and unexpected results with AI. Angular, some of the new features like signals and our resource API provide powerful tools to solve these problems elegantly. And hopefully by now, you've seen that the Angular team is working hard to make Angular an AI-forward framework. So I've shared some of the work that we've released in the last few months, including an official Angular rules file, MCP server, the AI tutor, WebGen code score. We've also released a new dedicated section of our documentation, angular.dev/AI, to provide best practices and resources for using Angular with AI, and hosted a bunch of live streams on the topic on our YouTube channel. And finally, we've been in the lab experimenting with what we've been calling the framework of the future. We asked ourselves, if we created a completely new framework from scratch that was designed specifically for AI, what would it look like? The team's uncovered some really interesting things, but please don't worry, we're not planning to deprecate Angular in favor of this new experimental framework. However, we do plan to learn from it and leverage these insights so we can make Angular better. So now that we've heard a bit about what the Angular team's doing, let's talk a little bit about what you might want to be focusing on. Like the rest of this presentation, these are very much my own thoughts, but if I were to guess who's going to be successful in the coming years, I'd break it down into a few different categories that I think will complement AI. First, we have deep technical experts. So LLMs will inevitably get better over time, but you're going to need deep technical experts on your team to challenge LLM output, ensure high quality code, debug challenging issues, and solve the most complex problems with the help of AI. Next up are strong product and engineering generalists, your technical and product Swiss Army knives. So another trend I've started to see is that AI is lowering the barrier to entry to using different technologies. And this is really exciting because it means we can more often use the right tool for the job rather than whatever technology you're most familiar with. In my experience, however, it can be challenging to create anything substantive with technologies I don't know a lot about. And it's frequently been the precursor to my unfixable pit of despair. And it's at that point that I generally take a deeper dive into the technology and learn more. And as a result, I think those individuals who are conversant in multiple technologies, willing to learn and have a strong product sense, will be able to effectively leverage AI to do a lot. And finally, we have context pipeline engineering experts. I do think there will be some flavor of context pipeline engineering that exists in the future, and it'll be some sort of specialized skill set that leverages a combination of domain, AI, and context engineering skills. I'm sure there will be more or variations of these three categories, but these are the first that came to mind for me. However, a common thread across all of these categories is continuing technical expertise paired with a knowledge of how to effectively use AI. So what does that mean for you? Here are what I did invest in for myself, right? One, keep learning. Don't use AI as a crutch that makes you lazy. Leverage their productivity and knowledge to make yourself an even stronger engineer. And LLMs are really good at teaching. Use this to your advantage. Two, tackle hard problems. Challenge yourself to be a creative problem solver. The world's changing. Get comfortable being uncomfortable and figuring out new ways to solve old problems. Next, start experimenting with AI if you haven't. Play around with AI to generate code or infuse your apps with generative functionality. It's really amazing what you can do. It's probably easier than you think if you're a little skeptical, and it's really fun. And then finally, explore AI concepts like rules files, context engineering, and MCP servers, all of which I've discussed today. Just, you know, peel back the onion a little bit, see what you can learn. So we've covered a lot of ground today, including what a vibe engineering future may or may not look like, why LLMs can struggle to generate high quality code, what high quality code even is, tools and resources to generate high quality code using AI, a potentially new industry altogether in context pipeline engineering, how to infuse your apps with AI functionality, the developer's role in the AI-driven future, and ways to set yourself up for success with AI. So I could have named this talk all of the things I think I figured out playing with AI over the last 7 months, and I'm really happy to have had the opportunity to share this with all of you. If you had asked me to describe the state of the world 12 months ago, I don't think I would have been close. So my thoughts and predictions may be way off base here. Nonetheless, I really hope you found this talk insightful, thought-provoking, and perhaps a little bit inspiring. So thank you so much for coming and for listening. And I think we have some time for Q&A. Go ahead.
Always stick to the most updated Angular, but Angular 20. And we will letting we probably mentioned earlier, a lot of the we have Copilot. A lot of the suggestions are always based off of old Angular versions. Is that something that could be fixed with rules, or is the answer to just wait until the corpus is trained on as more updated?
Yeah, you can absolutely fix that with rules. The question, if anyone didn't hear, was if your organization is using the latest version of Angular and you're running into problems with generating modern code, can you actually solve that with rules files, or do you have to wait? I've had great success just using the official Angular rules file, and it's worked really well. And in my experience, like I've had a few edge cases where, say, I didn't, there was one feature that it didn't work for, just update my rules file, and it works pretty well.
Yeah, so I thought your tool for updating your rules files based on the MCP server was really cool. How big of a productivity update have you seen since using them, just compared to using it for this file?
It's a good question. I'm not fully done with the tool, so not a ton yet, but I find it's helpful because I'll give you another example, which is actually the AI tutor. To effectively update that rules file was not as simple as just like putting a one-liner in and fixing it, because especially with kind of complex concepts that might touch across different places in the rules file, and it might be nuanced in terms of how you want to do it. So I almost created like a pipeline for myself to do that, where it was pretty sophisticated in terms of digesting what changes I wanted to make, figuring out how that fits into the existing rules and so forth. So that process, if I were to use that process for my rules files and actually code with that, it's like near impossible for me to get anything done. So with this kind of experimental setup that I had up there, it's actually really nice. Like the biggest productivity gain isn't anything to do with the rules themselves. It's more of keeping myself in that flow. That way I can keep coding and having the inputs that I wanted. Yeah. Any other questions? Going once, twice? So thank you all so much. Take care.